A simple infection, something that was easily treatable for decades, is now winning. The medicines we've relied on for generations have stopped working. This isn't science fiction. This is the reality of antimicrobial resistance, or AMR. Let's understand how antibiotics work. This is the cell city, where friendly microbes live in perfect harmony. These helpers keep everything running smoothly, but trouble arrives when hostile microbes invade. They multiply rapidly, damaging cells and driving friendly microbes away. The city falls into chaos. Just when things look darkest, our heroes, the antibiotics, arrive. They target and eliminate the troublemakers with precision, restoring peace to Cell City once again. When bacteria make us sick, doctors often prescribe antibiotics. These are powerful medicines, but how do they actually work inside our bodies? First, it's important to know there are two main types of antibiotics. Bactericidal antibiotics actually kill bacteria, while bacteriostatic antibiotics stop bacteria from growing and multiplying, allowing our immune system to finish the job. When we take antibiotics, they travel through our digestive system, get absorbed into our bloodstream, and are carried to infections wherever they're hiding. Antibiotics fight bacteria through several clever mechanisms. First, some antibiotics target bacterial DNA. They either break down the genetic material or prevent bacteria from copying their DNA, stopping them from reproducing. Second, other antibiotics work by binding to essential bacterial enzymes, preventing the bacteria from performing vital functions without these enzymes working properly. Third, many antibiotics prevent protein synthesis. They attach to bacterial ribosomes, the protein factories, and prevent bacteria from making the proteins they need to survive and multiply. Fourth, antibiotics like penicillin attack the bacterial cell wall. They inhibit the enzymes that build and repair the cell wall, making bacteria vulnerable. Without their protective outer layer, bacteria swell and burst. Antibiotics also vary in their range of effectiveness. Broad-spectrum antibiotics can treat many different types of bacterial infections, but they can also affect our beneficial gut bacteria. Narrow-spectrum antibiotics target only specific types of bacteria. This precision is exactly why antibiotics don't work on viral infections like colds or flu. Viruses have completely different structures and life cycles. Unlike bacteria, viruses invade our own cells, hijacking our cellular machinery to replicate. Antibiotics are designed to target bacterial structures that human cells don't have, so they can't touch viruses hiding inside our cells. Here's the dangerous transformation we accidentally cause. On the left, regular bacteria that our antibiotics can easily defeat. But when misused, these bacteria evolve into superbugs, larger, armored, and resistant to our medicines. The same treatment that once worked now bounces right off. The main causes of antibiotic resistance are simpler than you think. Stopping medication early lets the strongest germs survive and multiply. Using antibiotics for viral infections like common cold and flu, which they can't treat, self-medicating with old or shared prescriptions, and poor hygiene that helps superbugs spread. Each of these actions accidentally trains bacteria to become stronger. But there is hope. Here's how you can help. Be an antibiotic guardian. Only take prescribed antibiotics and always finish the course. Prevent infections through good hygiene and vaccinations. Spread awareness by sharing this knowledge with others. Remember, human, animal, and environmental health are all connected. The numbers don't lie. AMR already causes over 1.2 million deaths yearly. By 2050, this could reach 10 million if we don't act. This isn't just about medicine. It's about preserving modern healthcare as we know it. Share this message. Be part of the solution. Together, we can protect our antibiotics for future generations.